Welcome, students. Today we are going to differentiate between mixtures and pure substances. We are going to do this in a tabulated form. On the left, we have pure substances, and on the right, we have mixtures. Pure substances do have only one component, that is, they cannot be separated into any other kind of matter. An example is carbon. Carbon is an element and has a fixed composition. That is, it has exactly 12 atoms present in it. It has 6 electrons in its shells and 6 neutrons and protons in its nucleus. While mixtures are a combination of 2 or more pure substances. Example is air. Air is a combination of gases such as oxygen, nitrogen, carbon dioxide, and many other gases. All these gases are pure substances and are individually present in fixed ratios. A combination of these gases will form a mixture that is air. Another example would be a soil sample. In a soil sample, we have a combination of grass, stone, and sand particles. Let's proceed with the next difference. Pure substances do have a constant physical and chemical properties. Example, the boiling point of water is 100 degrees Celsius, while mixtures do have varying physical and chemical properties. These properties include melting point and boiling point. Let's consider a mixture of alcohol and water. The boiling point of alcohol mixed with water may be at a range of temperatures, while that of water is constant, that is at 100 degrees Celsius. Pure substances, they are pure and cannot be broken down using physical processes. Examples of these physical processes include evaporation and filtration. So these processes cannot be used to break down pure substances. Example, we have the element carbon. In this element carbon, we have atoms. These atoms cannot be broken down using physical processes, while mixtures are impure and can be broken down using physical processes such as evaporation, filtration, and gravity separation. Pure substances can be divided into elements, for example, the element hydrogen, and compounds, for example, the compound water, while mixtures can be divided into heterogeneous mixtures in which the components do not completely mix with each other, and homogeneous mixtures in which the components completely mix with each other. Let's now differentiate between compounds and mixtures. Compounds are pure substances, while mixtures are impure substances. Compounds are made of two or more elements which combine chemically. For example, we have two hydrogen elements and two chlorine elements. Their atoms combine with each other to form the compound hydrogen chloride. While in mixtures, we have two or more substances mixing physically. Example would be a mixture of rice and beans. Let's proceed with another difference. Compounds have fixed properties. That is, a particular compound will have a fixed temperature at which it melts and boils, while mixtures do not have a fixed property. That is, their properties depend on the nature of their components and the ratios in which they are combined. The constituents of a compound are present in a fixed ratio. For example, we have the compound hydrogen chloride. In this compound, we have one atom of hydrogen and one atom of chlorine. They combine in a fixed ratio of 1:1 to form the compound hydrogen chloride. While in mixtures, the constituents of the mixture are present in varying ratios. For example, in the mixture of rice and beans, the ratio of rice is to beans grains cannot be determined. Tell me, can you count the number of rice grains and beans found in a plate? I don't think you can determine that. Let's proceed with another difference between compounds and mixtures. The constituents of a compound can be separated by chemical methods. In chemical methods, the substance is altered chemically This is done by chemical reactions which change pure substances into new substances through a chemical reaction. Evidence of this is a color change, or a gas may be evolved, or there may be a change in temperature, or a combination of two of these or the three. While in mixtures, they can be separated using physical methods. Examples of these physical methods are evaporation and filtration. And in physical methods, the substance is not altered chemically. That is to say, there is no bond breaking or making. In compounds, a new substance or new substances is or are formed, while in mixtures, no new substance is formed. The picture below gives you an example of a compound. In this compound, we have a combination of two compounds. The first compound is methane, reacting with oxygen to form new substances or new compounds, which are carbon dioxide and water. As we earlier said, in mixtures, no new substance is being formed. So, if you have a mixture of cookies and milk in a bowl, it is equal to cookies and milk. No new substance has been formed. You will still have the same amount of cookies and milk present in the bowl. Thanks for your kind attention.